Hi folks, today we are going to try doing a little bit of a simulated practical. When you click on the link you'll see a screen that looks a bit like this. It will load up and then you'll get these 4 boxes. I want you to click on the one that says lab. You need to click on it twice. Once sort of zooms in on it, second time opens up this. There's an awful lot of widgets and tools and things that you can use on this. We're not going to use very many of them to start off with, so to tidy it up a bit and make it look a little bit more sensible, I'm going to minimize that so it's not cluttering up the space. This tool here is a ruler, so if you click on it you can pick it up and move it around wherever you want. I'm just going to leave it there for the time being so it's out of the way. Everything else, just leave it alone. Don't click on anything else. Don't change any other settings. Okay, I'm also going to add this kind of virtual piece of paper here so that I can show you the kind of things you need to be writing down and making note of as we go. Right then, so we've been looking a little bit at pressure and how pressure affects liquids and gases, but we can also look at force and how force on its own can change the shape of things, how it can deform things, and how much those objects change depending on how much force we apply. And to do that we are going to use this little simulation here to look at how different forces affect this spring. The very first thing you need to do is move the ruler so that it is pretty much in line with this little black spot here. You can move it a little bit closer because that's how we are going to measure how much this spring extends. We're not really interested in how long the spring is to start off with. What we're interested in is how much longer does it get, so what extra length does it get. We could do this a slightly different way. We could measure the length of the whole spring, and every single time we add a mass, measure the length of the whole spring, but we'd still need to take away the original length of the spring every single time. The easier ways to do it is just to only measure how much longer it gets when we start putting masses on it. So when it has 0 mass hanging off it, its extension is 0. We are going to use this orange mass down here. Quite helpfully it's got 100 grams written on it to start off with, so I'm going to write that down as my first result. So we're going to put 100 grams on. Now whenever you add the mass, all you do is click and drag to attach it. Because it will immediately start moving the spring while you've got your finger clicked down, it will start bouncing around like that. So actually it's a really sophisticated simulation, but we're not interested in the bouncing. So if you press this red button here, that kind of zooms fast forwards to the end of the bouncing and stops it from moving anymore. Now I can now measure how much the spring has extended. That looks to me about 1.5 centimeters, so I'm going to write that down. 1.5. Now this little panel up here is the control panel for this little mass. Unfortunately you can't just enter the numbers straight in here. You do have to click across or use the slider. I can never get it to manage to get it exactly where I want it to land. So if you move it across a bit and then click, when you do change it, it'll start bouncing again. So make sure you press the red button to stop it. So now I've got 120 grams on, and that looks about 2 centimeters to me. 2.0. The ruler is measured in millimeters, so it says 10, but that means millimeters. I've converted that into centimeters each time, so 15 millimeters 1.5 centimeters, 20 millimeters, 2.0 centimeters. You want to keep going like that, taking more results, and use them to fill in your results table. So I've put in an example here. If I had a mass of 500 grams, I need to convert it into kilograms. You know that there are 1,000 grams in a kilogram, so 500 grams must be 0.5 kilograms. We then need to convert that mass into a weight. You know how to do that. We did a lesson on the difference between mass and weight. You find out your weight by multiplying your mass by the gravitational field strength on Earth, which is 10. So the weight is 5 newtons. You don't need to write this sum out every single time. So if we had an extension of 30 centimeters, that would give us an extension of 0.3 meters. So just to do one more example, so this result here that we took, 100 grams, that would be the same as 0.1 kilograms. Multiply it by 10, 1 newton. 1.5 centimeters is going to be the same as 0.015 meters. Okay. I would like you to take at least 8 results. Okay. I think increasing it by 20 grams each time is a sensible amount, but it's really up to you. Then I would like to have a think about what is the independent variable in this experiment, what is the dependent variable. Think about some control variables, and then draw a graph. You can use whatever skills you've got, whatever tools you've got. If you've only got squared paper or lined paper or even plain paper, just do the best you can. Have a think about what results need to go where. I've highlighted weight and extension because those are the two that I want you to put on your graph, but have a think about which axis they go on. I've put some instructions for an extension task, some questions for you to have a think about. What you could also do, if you come back to the simulation, if you look at this control widget here, you can move it around to change something called the spring constant. Have a bit of an investigation of how this affects how much the spring can extend for the same amount of mass. So you could put 120 grams on it and then go for a small spring constant and a large spring constant. Investigate the difference. Yeah, you could also produce another graph for the same masses. So we did 100 and 120, so if you carried on like that, 140, 160 and so on, produce another set of results using a very large spring constant and see how different that looks on your graph.